So distance, displacement, speed, velocity, and in velocity we have discussed the average velocity, the instantaneous velocity, the constant velocity, like this one. And then the acceleration. So in acceleration, again we have instantaneous acceleration and the average acceleration. Okay. And then we have discussed the equations of motions, equation of motion for constant acceleration, for constant acceleration. Okay. And at the last, we discussed the free fall motion, free fall motion. So these are the articles which we have discussed in chapter number 2. Now we want to see the displacement time, the velocity time graph. So our target is today to understand the displacement time graph and the velocity time graph, and then from velocity time graph, the acceleration time graph. This is our target. So remember, if you want to take the first derivative of displacement time graph, the first derivative of displacement time graph or displacement, then it is called velocity. If you take, I mean that dx over dt, this is equal to v. So dv over dt, this is equal to a. So if we find dA over dt, here we are finding nothing, but this is called jerk, but we are not studying this one. Okay. So we are studying only this, or this. Okay. So our focus is today, our focus is on the graphical pictures and we will solve somewhat problems. Let's see in the next page. So first I will discuss the straight line graphs. Straight line graphs mean where the slope is constant. For constant slope, you can understand like this one. For constant slope. So if we have, this is displacement time graph and the line is straight and this is angle theta. If I draw the line here parallel to time axis, if I draw the line here parallel to time axis, this angle theta, this angle theta. So angle theta here, it is called slope. Theta is actually slope. So slope is in this graph is constant. So slope mean velocity. Slope mean velocity. So it means if slope is constant, then velocity is constant. One thing. So here from this graph, we conclude that our velocity is constant. Yes? Walaikum assalam. Yeah. Last day I opened the door. Student, just 1 minute, okay? Just 1 minute. You can take a sorry. Okay, so slope mean velocity. Velocity is constant. So here from this graph, we can say that velocity is constant. One thing. The second thing, we cannot say up to this information that velocity is constant, either it is constant in positive side or in negative side. This is another question. So if your this angle is theta angle is less than 90 degree. So remember, if the lines are like this one, surely it is less than 90 degree. If the lines are like this one, it is greater than 90 degree. Okay. So if theta is less than 90 degree, then V will be positive. So from here, we conclude that velocity is constant and positive. Constant and positive. So if it is constant and positive, the graph line will be constant, mean it is like this one, straight line, parallel to time axis. It is constant and positive. One thing. The second thing, if you want to plot a graph of acceleration time, so if the velocity is constant for the whole time, then the change in velocity will be, if this is 5, this is 5, this is 5. So 5 minus 5 over t is what? Is 0. So acceleration time graph will be like this one. You understand or not? Yes, student.
Excuse me, doctor.
Yes.
Can you please explain again how is theta less than 90?
How is the less than 90? Yes.
Yeah.
This angle is 90. This angle is 90. Okay. Oh, this angle is 90, or this is 90 degree with this one. Okay. So if I make the angle between, this is 90. Okay. If I put this line here, then this will be greater than 90 or less than 90?
Less than 90.
Less than 90. So I write here less than 90. If it is less than 90, then V will be positive. Okay.
Thank you so much.
Okay. After this, I think you understand this one. Huh? After this, if our displacement time graph is a straight line like this one, it is constant. Now the displacement time is constant. What is the slope here? Slope is 0. If slope is 0, the velocity will be what? Slope
0.
is velocity. So velocity will be 0. So what will be the graph? Graph will not will be here, not will be here. It will be 0. Okay. What will be the acceleration time graph? It is 0. So it will be here. Clear?
Clear.
Okay. After this is xt graph, and the graph line is this one. Okay. Now we want to find the VT graph and the AT graph. Okay. So here slope is constant or variable? Slope is constant. If you want to find the slope at every point, it is constant. So slope constant mean what? V constant. One thing. The second thing, the theta is greater than 90 or less than 90?
Less than 90.
Less than 90. How?
Oh no, it's greater than 90.
It is greater than 90. If you draw this line, extend this line, then this angle is, you can measure this angle. So this is greater than 90.
Yes.
So if it is greater than 90, then V will be what? Positive
Minus.
or negative? Minus.
Negative.
Negative. So we have concluded two things. One is V is constant and negative. So this is V and this is T. So V is negative, constant and negative. Negative, this side. Okay. One thing. What will be the AT?
0.
0. Surely 0. Because the change in velocity is constant. Change in velocity is 0. So it is 0. If I put here 10, Okay. So what will be the answer? 0. Okay. So after this, we have this graph, X and T. Okay. This is the angle, theta. Slope is constant or variable. This line, this line, this line, this theta. So slope is constant. Slope is constant. Velocity is constant. Theta is greater than 90 and velocity will be negative. So if you want to make a VT graph, what will be the answer? Velocity is negative and constant again. So this is the line. So you can draw a AT graph here again. If V is constant, then acceleration will be velocity. Acceleration 0 mean what? Remember, acceleration 0 mean what? Acceleration 0 mean the change in velocity is constant. So the change in velocity is constant, acceleration will be 0. So constant velocity mean what? 0 acceleration. Constant velocity mean 0 acceleration. Okay. After this, I'm making the straight lines like this one. Okay. The line is this one, X and T. So here angle is this one. R angle is this one. R angle is this one. The lines are like this one. Then theta is less than 90. So if theta is less than 90, V is positive. So V is positive. Slope is changing or constant? It is constant. Straight line like this one, like this one, like this one. It is constant slope. So slope is constant. So slope constant mean velocity is constant. So same thing, but in positive side. So this is positive side. This is VT. So if this is VT, then what will be the AT? The same at 0 level. So remember, in this chapter, your AT graph either will be here, or will be here, or will be here. It is not like, remember that your AT graph will not be like this one. Okay. Will not be like this one. Mostly it is like this one. Okay, after this. So this is all the cases I have discussed in which the line is straight. Straight mean like this, like this, like this, like this. Okay. I have discussed all these cases. Now, I am going to the curved lines. So up to now, you understand this one? I think.
Yes, doctor.
Yes,
Okay.
yes.
Now we have the curved graphs. Curved graphs. So in curved graphs, this is X, this is T. Already we have discussed this one. This is the graph. This is tangent line. This is tangent line. This is tangent line. This is theta. This is theta. This is theta. First, see here theta is less than 90 or greater than 90. It is less than 90. It is like this one. Okay. So it is less than 90. One thing. So V is positive and the theta is decreasing or increasing. I make it again. If I put it here, then I put it here, then I put it here. So the theta is increasing?
Increasing.
Yes, increasing. Theta is increasing. And remember here, you will say that it is positive and increasing constantly. Increasing constantly. Okay. So if it is increasing and constantly, then what will be the VT graph? VT graph is positive. Positive in this way. Okay. And increasing constantly. So it is increasing constantly. So from here, the graph will be this one. From here, the AT graph will be what? The slope is increasing or constant?
Positive, constantly positive. The
Yes.
acceleration.
Yes, it is.
Acceleration, I think
Yes,
it
it
would
is
be a
increasing.
straight line.
Yes, it is increasing. V is increasing. So it means
The
A
acceleration
will
is
be
Acceleration is
positive
increasing.
and constant. A will be positive and constant. Okay, understand? After this, the graph line is like this one. Here is tangent. Here is tangent. Here is tangent. The angle is increasing or decreasing? First is angle is less than 90 degree. Less than 90 because the lines are this one. Less than 90 degree. So V is positive. One thing. The slope is increasing or decreasing? It is
Increase.
decrease.
Why,
See,
teacher?
it is this one. I put the line here. This is angle theta. I put the point here. It is angle here. This angle is greater and this angle is more greater. If I put the line here and draw the tangent line, so the angle is increasing or decreasing?
In the back, decrease.
The back decrease mean what?
When to go up.
You will measure the angle from here. Slope is decreasing. So V is decreasing. A will be positive or negative?
Positive.
A will be
Negative.
negative. A will be negative.
Because velocity is decreasing.
Decreasing. So your VT graph will be what? Is decreasing, constantly decreasing. Here we always use the word constantly. So constantly decreasing graph will be this one. Constantly increasing graph of VT is this one. This is constantly increasing. This is constantly decreasing. So what will be the acceleration time graph? Acceleration time graph will be negative, but constant, this one. If your case is this one, then acceleration will be positive and like this one. This is AT graph of this one. Okay. Understand? After this.
Yes, and clear.
Now we have this graph. XT is like this one. 1 point is here, 1 point is here, 1 point is here. Okay. So if I draw the line of tangent, see the tangent line. See the tangent line. See the tangent line like this one. So the angle theta is greater than 90 or less than 90 from here?
Less.
Oh, less. So brother, it is greater than 90. I said that if the lines are like this, then it is greater than 90. If the lines are like this, it is less than 90. Because your 90 degree is here. If I draw the lines less than 90, then I make the line like this one. If the angle is greater than 90, I draw the line like this one.
Mm.
So understand this one. You should control these things. Okay.
Okay.
So theta is greater than 90. So if theta is greater than 90, V will be negative or positive? Negative. Negative. Okay. So it is negative. So the angle is increasing or decreasing? Angle means theta is increasing or decreasing? Slope. Slope
Increasing.
theta is increasing because it is here, more. So increasing. So slope is increasing, but negatively increasing. Mean what will be the VT graph? I'm making this graph on the next slide. See this one. The graph is this one. What will be the VT graph? So the graph is, we have seen that V is negative and increasing. Theta is increasing. So what will be the VT graph? So VT graph will be this one. Negative but increasing. So what will be the AT graph? Yes. AT graph will be what? If you want to find this graph,
It will be I think straight line from the 0 to it will be positive.
it will be positive. If we take the values, you can see this value. If this is -2 and this is suppose -4 and this is 1, this is 2. Okay. If you find the slope of this one and this one, what will be the answer? Yes, slope was what? y2 minus y1 over x2 minus x1. This is the formula of the slope. Okay. So if you take this point, what is this point? This is 2 over -4. And what is this point? This point is 1 over -2. Okay. Now find the slope. Check the slope. So if I find the slope -4 y2, this is my y2. -4 minus this formula and -2 over x2, 2 minus 1. Answer is what? -4 plus 2 over 1
It will be -2.
-2. So it means the slope is negative. Okay. So AT graph will be where? Negative side. Okay, clear? Understood.
Doctor,
Yes.
then acceleration is not increasing.
Yes, acceleration is negative here. In this case, acceleration is negative side.
Even if the slope is increasing, so the acceleration will
Okay,
be,
see, no, okay, I give
increasing.
you one conclusion. Okay, see this one. If you have this graph, suppose it's this concave is up or down. It's this concave. This is called concave. You know this in mathematics. This is called concave line. Okay. One concave is here. One concave is here. So this concave is down and this concave is up. So here concave is, I'm writing concave. Understand this one. This is very good concept. concave is up. If
Mhm.
concave is up, then A will be positive. Okay.
Okay.
Theta is less than 90, then V will be positive. So if A positive and V positive, both same sign,
Fine.
then speed will be increase or decrease. Speed will be
Increase.
increase. This is one concept. Okay.
Mhm.
And then xt, if I make the like this one, the concave is not up, it is like down. Okay.
Down. Yeah.
It is down. So concave is down. If concave is down, then A will be negative.
Negative.
Okay. And
Yes.
theta is less than 90. In this case, theta is less than 90.
Mhm.
Okay. So theta is less than 90 mean V is negative and decreasing. Okay. And decreasing. So what you will decide? Same sign, the speed is increasing or decreasing? Same sign, the speed is
Speed is decreasing.
huh?
Oh,
Increasing.
increasing.
If the same sign, the speed is increasing. If one is positive, suppose A is positive and V is negative, or V is positive or A is negative, then opposite sign, then speed is decreasing. So remember this notations.
Okay.
Okay. After this, if you throw the ball up and the ball is going down, first up and down, what will be the xt graph? Xt graph will be like this one. Huh? So what will be the velocity time graph? Yes. From here to here, the speed is increasing or decreasing? From point O to A, the speed is increasing or decreasing? The velocity is increasing or decreasing?
Increasing.
Huh?
Increasing.
How increasing? At this point, the velocity becomes zero or maximum?
Zero.
Zero.
I said decreasing.
Decreasing. Okay, if you said decreasing is okay. So it means it is decreasing. So if it is decreasing, the graph up to O and A, the graph line of VT will be like this one. This point is showing what? The velocity is zero. So this is A point here. So after A to B point, the velocity is increasing or decreasing? From A to B, it is increasing or decreasing? Yes. Any smart student? You are 103 student. Mashallah, you are intelligent students. From A to B, when the ball is moving down, its velocity is increasing or decreasing?
Increasing.
Increasing. Okay, it is increasing, but in negative direction. Okay.
Yes.
So the line will be like this one. From A to B, the line will be this one. So if you want to draw the AT graph, what will be the AT graph of this one? It is negative. It is here. What will be the AT graph of this line? It will be the same like this one. You can take the values and find. Then you can see that the line will be here or here. Okay. It's a better way is this one to understand. Okay. So this is all about graphical explanations, which I want to give you. So in the graphical explanation, you maybe some more graphical explanation I will tell you. Okay. So now I want to start this some problems of this chapter, and let's see. Okay, now you can see this window in the Excel. Sorry, this PowerPoint slide you can see.
Yes, sir.
Okay. So here are some same problems which already I have discussed with you, but this is just for your revision. Okay. So any other problem which you cannot solve at your house, you can send me. Okay. I will solve and I will discuss with you. Okay. If you have any question, any problem. So this is the problem which is related with the distance and the displacement. Already I have discussed. So from x2 to x minus 13 is what? This is 0 and suppose this is 2 and this is minus 13. So a body is moving from x is equal to 2 to x is equal to 13 here and then returns to minus 5. Come here. Find the displacement and the distance. So the displacement was what? Displacement was final position minus initial
Initial.
position. So the final position is minus 5 and the initial is 2. So you can write this value minus 7 meter. And what is the distance? So the distance
minus
is
13.
minus 13 to, but just add this one. 2, 13 and 5. How much? Not 5.
From what?
What is the answer of this one? Distance.
Is it 20, Doctor?
It will be, I think it will be 23.
Why 23, Doctor?
Why?
Yes. Count this one. If this is 1, minus 1, minus 2, minus 3, minus 4, 5, 6, 7, 8, 9, and 10, 11, 12. How much this one distance? And then come back to here.
Yes, that's right. It's 23.
This is
Uh,
0,
from-
this is 13. 13
Yeah,
is this one, 2 is this one.
From 2 to 30 to minus 13 is 15
This is 15.
meter.
Okay,
Yeah,
15.
and from minus 13,
13 to
to
5.
minus 5 is 8.
8.
So it's
So
23.
total is 23.
Yes.
Okay. Because in distance, you just count this one. Okay. After this, I have discussed this again problem. So you can see a person walks first at a constant speed of 5 meters per second along a straight line from A to B. So this is A and this is B. So its speed is given 5 meters per second, but don't mention the distance. Distance, you will take D. From B to A. From A to point B and then back along the line from B to A. B to A. So is how much? 3 meters per second. The distance is same. What is his average speed? So average speed, I have already discussed, the total distance divided by the total time. So D plus D, we don't know the values of D. Divided by T1 plus T2. So 2D divided by T1, for this one is T1. The distance is D. So the you know the distance is what? Speed into time. Okay. So time T1 will be D over 5 and here T2 is D over 3. So you will put T1 d over 5 plus d over 3 and then solve it. So this will cancel. So answer is 1 over 3 plus 1 over 5. So you can solve this one and get the answer. This is the same problem which I have discussed before. His average velocity. This is average speed. So average velocity is, this is the d distance in the right side and this is the d distance in the left side. So velocity is displacement over time. So d plus and d minus, answer will be 0 over t and this is 0. Okay. Velocity will be 0 and speed will be this one. Clear?
Clear.
Okay, after this, a runner, again the same thing. A runner goes completely round a circular track of radius this one at a constant speed of this one. So circular track mean what? Circular track mean if he is starting from here and come back to here. So it means his displacement is 0. His displacement is 0. So if its displacement is 0, the average velocity will be 0. Remember this one. Okay. After this, the position of a particle moving along the x-axis is given by this one. X is equal to 21 plus 22t minus 6t square. What is the average velocity? So average velocity at time
Derivative.
t1 is 1 second and t2 is 3 second. Okay, 3 second. So you will find the x1 first. 21 plus 22 into 1 minus 6 into 1 square. So you can find this value. And x2 will be what? 21 plus 22 into 3 minus 6 into 3 square. So you can solve it and get the answer. So V
Okay.
average will be, yes,
Don't you have to take the derivative first, then solve it?
again, what you say?
Didn't you have to take the derivative first, then
No,
solve it?
derivative, we don't need the derivative because he is asking the average velocity. For the derivative, we need for the instantaneous velocity, okay?
Oh, okay, thank you.
So x2 is minus x1 over t2 minus t1. Last time I explained that if you want to find the average velocity, you need 2 times. For instantaneous velocity, only 1 time, because you are finding the velocity for that particular time, that is the tangent line. Okay. Okay, after this. So the position of the particle is this one and x is in meter and t. What is the position of the particle when it reaches its maximum speed in the positive x direction? So remember the maximum speed. How you can find the maximum speed? This is important. X is equal to 6t square minus 1t cube. Find the dx over dt here. So dx over dt is what? Yes.
Is
12t
12t
minus 3t over square.
3t square. What is the position of the particle when it achieves its maximum speed? Yes. So when it achieves maximum speed, then you will put this derivative 0. I think so. This is okay. Okay. What is the answer? No. This is not answer. No. 6t square. This is 6t. Okay. If I think here is a value is wrong, I think. Okay, if we want to find the t value, Then answer is what? 12 minus, sorry, 4 minus, no, this question has a problem here. Maybe it is a t
There's no time to solve it.
minus 60. Huh?
They didn't give us time to solve it.
No. Actually, I put here wrong. Here is 12t and here is t 3t square. This is okay. And then dv over dt is 0. Maximum speed will be when the derivative is 0. So when derivative is 0, then this is 12t minus. Oh, no. We have to put not a derivative 0. We have to put the acceleration 0. Acceleration. But this is not according to your syllabus, I think. So leave this one. We will not solve this because they will not give you like this type of problems. Okay. See this one. A car starts from rest and accelerates at 4 meters per second square for 5 seconds. So accelerates. It means from here you can conclude that this is the acceleration value. Always check the units. This is time. This is acceleration. This is also acceleration. This is time. Okay. And this is also time. So acceleration is 4 meters per second square. It starts from rest. So initial velocity is 0. How much time? Up to this one, 5 seconds. Okay. So then maintains that velocity for 10 seconds and then deaccelerate. Deaccelerate mean its acceleration is negative. Deacceleration mean negative acceleration.
Negative acceleration.
At the rate of this one for 4 seconds. What is the final speed of the car? So you just find the final speed. So final speed is what? Vf is equal to Vi plus At. We know this equation. So Vf is equal to 0 plus A. A is what? 4 into
4.
5. And this is 20 meters per second. So it maintains this speed, this velocity. How much time? 10 seconds. Okay. This velocity maintains. And what you want to find? You want to find the velocity when it deaccelerates at this value. So this is your value. You can understand this question. The car is moving with this velocity. With this velocity mean 20 meters per second. Now the deacceleration is starting. It means you are applying the brakes.
We can
So-
use the same.
Yes, when you
Okay.
apply the brakes, now you need the final velocity. Not
Yeah,
this.
we need the final velocity. So the initial velocity is 20 that we
Yes.
we already did,
Yes,
and the acceleration is
20
2
minus
2.
2 into 4.
Yes, exactly.
So 20 minus 8 is equal to 12 meters. This is the answer. Now understand, actually the car is starting. First, the car is starting from rest. Its initial velocity was 0.
0. Yes.
This statement is up to here. Up to here. Okay. So it is moving with acceleration 4 meters per second square.
For 5 seconds.
So you find the final velocity at this situation. So when you find the final velocity, it is 20 meters. Now it is moving with 20 meters per second. Then brakes are applying. When brakes are applying, it shows deceleration, mean negative acceleration. So you need the final velocity. Now this velocity which you have find here, the final, it will become the initial and the final new you will find like this one. This is what we want to ask. Okay. So here are some other problems that are simple. So you can solve it yourself. I will send you. So I want to solve this problem. This is a little technical. It comes in the previous exam, I think. Okay, see this problem. A rocket is fired vertically upward with an initial velocity of 80 meters per second from the ground level. So vertically, this is a vertical motion. So initial velocity is what? This is the initial velocity,
Is 80 meter per second
is 80 meters per second.
and accelerate
And accelerate. So its acceleration is giving. You
4
will not
meter per
put the
second.
G value, 4 meters per second square, until it reaches an altitude of 1000.
1000
Altitude
meter.
mean the length. So the distance is 1000 meters. When it reaches here, at that point, its engine fail. And the rocket moves under the influence of Earth's gravity only with an acceleration of minus 9.8 meters per second. So when it reaches at this level, from this ground level to this level, the distance is how much? Its height is 100 meters. And the engine fail. When engine fail, it will stop here? No. With this acceleration, it will move some forward. Okay. Now the question is, when the engine fail, this acceleration finish. So where at this stage, the acceleration is starting 9.8 meters per second square because it is moving in free fall motion. So the question is maximum altitude of the rocket from the ground. He is asking that from this point to this point, how much distance he covered from here to here. Up to now, we know it is 1000. From here to here, what is that distance? And you will add this distance in 1000 and this is your answer. Understand? So from here to here, how we can solve this one? Okay, I solve this with some a little tricky way. We want to discuss it. Okay, see this one. If the rocket is moving up, we know the distance. Okay, the height or the distance. Height is what? 1000 meter. Initial velocity is what? 80
80
meter per second
per
square.
second.
Acceleration is what?
4
4
meter per second.
meter per second square. Okay. So apply the formula. Up to this, what is the final velocity? So to find the final velocity, Vf square minus Vi square is equal to 2. Actually, we are using 2gh. Okay. But here it is not g. It is this value. So Vf square, we don't know the Vf here. We want to find this one. Vi is what? 80. 2 into g. G mean this 4. H mean this distance. So we will solve this equation for Vf. So Vf will be what? So this is 8000, 2004, 8000 plus 80 square and under root. So when you solve this one, your answer will be 120 meter per second. So it means up to 1000, covering 1000 meter, its final velocity is 120 meter per second when engine fail. Okay. So what will be the time? So to find, can we find the time here? Yes. We find the velocity. Can we find the time? Yes, we can find the time. We can find the time, brother. Understand or not?
Yes,
So-
doctor, but it's a
Ye-
little bit tricky.
Yes, we will find the time. Vi plus GT. Okay. GT mean 80. So Vf is what? 120. Vi is what?
VI
Okay.
is
Vi is 80. Okay. Plus G is what?
acceleration
Yes, acceleration is what? 4 into T.
4.
So can you find the time here? It means this is the time it is from this point to this point. It takes how much time? I find this time.
So, it's 120 minus 80.
Yes, 120 minus 80 is what? 40?
on
and 40, and this is 10 seconds. How much time it will take from A to this point? It will take
10 seconds.
10 seconds, okay? So we need what? We need actually this distance
The
from
fin-
here to
the-
here. Or this, we know that this distance is 1000, okay? So what we will do? We will find this distance. To find this distance, we know that the body is moving under gravity. The body is moving under gravity. So it is moving under gravity. So what you will do? You will apply the formula. Watch. It is now maximum position. Maximum position, the final velocity is what? What?
0.
0. It is 0. When it is here, what is the velocity?
120.
120. Okay. So is equal to 2 into G. G is what?
9.8.
Minus 9.8. And what is height? We want to find this height. We want to find this height, okay? We don't know the height. We want to find this height. So when you solve this one, you will get the answer. It is 735 around. So what is the total distance from here to here? 1000 plus
1000.
735. So answer will be 1735. So time, I think you don't need, but if he asks the time, then you will find the time. Now understand or not? Okay. This is another question, but I am again see this one.
Doctor,
Yes.
we have
Other
a class.
Okay, so
Yeah.
next, I have also class. Okay. Okay, see you in the next lecture and we will solve the problems more.
Thank you, Doctor.
Thank you very much, Doctor.
Okay, salam alaikum.
Doctor, will you gonna send this?
Yes, I will
PowerPoint?
send. I will send. Yes.
Okay, thank you.